All right, thank you very much. Sounds like I'm the last thing that stands between you and like having drinks and wrapping this up. So I will try to keep it short and interesting if I can. And I promise I also have a couple of demos at the end, so it will not be just like dry watching me talking to slides. I want to talk to you today a little bit about Mozilla's vision for WebRTC and also explain a little bit why it's so critical to us. As the introduction already said, I'm responsible for mobile at Mozilla, and WebRTC is one of the areas I'm responsible for. And we have been very strategically invested in WebRTC for quite a while now. And along with a couple others, such as Google, we are really pushing the technology stack forward and shipping it in Firefox these days. And I've explained to you a little bit why this is so important to us. Before I do that, I want to talk a little bit about Mozilla and what we are and what we do and why we do what we do. And I think it's pretty important to understand really what Mozilla is at its core to realize some of the things that we are doing and maybe also the rationale why we are doing them. Mozilla is a fairly unusual entity, especially if you compare us with a commercial corporation like Google. We are most known for our Firefox product. We have hundreds of millions of users using that in many, many different languages. And this product is engineered by almost 1,000 employees these days across the world. I think we have offices in 15 countries. So we have this like really large corporation making software, but what's so unusual about it is actually it is owned by a nonprofit foundation. So really at its heart, Mozilla is a nonprofit foundation. We don't have shareholders in that sense. We really just have a mission. And I will talk about that at length over the next couple of slides. And but other things unusual about Mozilla is our scale. If you look at how large we are a little bit less than 1,000 people. If you compare that with entities like Google or Microsoft, we're really tiny. We probably have fewer employees than Microsoft as janitors. And the reason that we can keep up making products like Firefox and making competitive products like Firefox is that we're actually much more than just the engineers that the foundation is able to afford through employment. We have a very large community of developers who are arranged kind of around this core of engineers the foundation employs, and this large community of thousands of people are really the ones who are developing Firefox. So being an open source project and being driven by a nonprofit foundation is really very central to who we are. I just heard a comparison in a previous keynote where someone was taking you back to 1995, where the internet was really just a collection of pages. And I want to do the same a little bit and kind of go back in history to understand a little bit where Mozilla is coming from and what our experience has been over the last 10 or 15 years. If you look at us today, really, over the last 10 years, the core things that have driven us were to provide choice to users, to give you the ability to choose between technology implementations you want to use. So the fact that you today can choose between like Chrome and IE and Safari and Firefox is something at the very core of our mission. We believe that this kind of competition between products is very important. And the second driving key piece for us is innovation. We want to move the web forward to innovation. And we'll show you in a second why that's important. Now, before I talk about today, I want to talk a little bit about the past, just as the previous speaker. Who remembers here IE6 and that famous web like the previous speaker talked about where you have links? Like, who remembers IE6? Excellent. A lot of people remember that. What is the one thing that you, like the top thing comes to your mind about IE6? It totally sucked. Excellent. Very good answer. Why did it suck so much? So back at this time, Mozilla barely existed. So what happened is that Netscape Corporation was really the first company that created a commercial browser product out of some academic work that happened earlier. And Netscape had fantastic growth. Before Netscape, really the web was just kind of like text and being entered into a terminal. For the first time, there was a commercial product to explore the web as this like hyperlinked collection of documents. So it was very, very popular. A lot of people started using it. And Netscape found itself in the middle of this growth path. And they had a certain business model behind this. The business model was that if you're a non-commercial user, you can use it for free. If you're a commercial user, you can go and pay Netscape some money, then you can use the browser as well. Worked very well in the beginning until Microsoft came in and offered IE bundled with Windows as an alternative to Netscape, and they changed up the business model a little bit. The business model was that if you use it non-commercially, it's free. If you use it commercially, it's free as well. That was, of course, very bad for Netscape, and Netscape very shortly went out of business. That's kind of the story that everyone knows. There's a couple more sinister parts of the story that also contributed to Netscape's decline. One that's more known is that Microsoft, of course, bundled IE with Netscape. They bundled IE with Windows. As a result, there was not a strong reason to download Netscape anymore because we had a browser with the operating system. So that was one part of the equation. But actually, there were a couple more sinister things going on. The second thing that happened is that Microsoft started to also push a bunch of proprietary technologies into the stack. Very famously, ActiveX was a piece of technology where basically Microsoft took Windows code and made it possible to run that in the web. And what happened is that very suddenly, you could only use IE really to use the entire web. And there were kind of two parts of this equation. The first reason that this took off is that ActiveX genuinely added certain things that the web back then didn't support. As we just heard, back then, the web was this kind of static set of pages where you can click on links, and all of a sudden, ActiveX exposed all the capabilities of the native Windows platform to the web. So sites wanted to use that. If you were a car showroom, you wanted to use all the cool, flashy effects ActiveX offered. So you started using these ActiveX controls. And on the other hand, of course, you had this overwhelming market power, where like suddenly a very large share of people had IE, so Microsoft could use this proprietary technology to start delivering content. The results were actually very devastating for everyone else who was trying to make a browser, because all of a sudden, you didn't really know anymore how to make a browser. The only people who knew how to make a complete browser that could render all of the web were Microsoft, because nobody else really knew how to use ActiveX, and even if you did, you couldn't really build it because it was heavily patented by Microsoft. So today, we find ourselves in a very different situation, of course. Like today, as everyone knows, HTML5 is here. And we are today in a place where there is a layer of standards that the web is based on around HTML5 and a couple other standards. And of course, WebRTC is joining this kind of family of standards that make up the web today. And there's a lot of content. And that content is written against these standards. As a result, you have all these different implementations of browsers. You have, of course, Firefox that we make, but also all these other browsers. And often they have competing rendering engine implementations. So 4 out of these 5 browsers use a different implementation of these standards to render web content, yet they can now interoperate. So it doesn't matter whether I use Firefox or Chrome, if I go to asm.js, the content is going to work the same in both of these browsers. And that's really the achievement of HTML5 standards. And it's very important to understand how we actually got here to kind of realize why WebRTC is so important, or such an important addition to HTML5. I have a little example to show you how this really works in the browser world. You have the graph here, and the graph relates to a certain piece of technology in HTML5 called JavaScript. JavaScript is really the underlying programming language of the web. And all these different browsers have to implement a virtual machine to run JavaScript. And for a certain amount of time, we competed heavily over the performance of JavaScript. So what happened is that one vendor came up with a new set of benchmarks called the V8 benchmarks. And they happened to release this at the same time with their browser, Chrome, which had the VM called V8 in there. So this was a very clever move. If you ever want to make a VM, always release a benchmark for this new VM at the same time that you're winning on at the time that you're releasing it. So it was a very clever move, because all of a sudden they came out with this new benchmark, and of course, lo and behold, it's their benchmark. They're really good at it. So if you look at these graphs, the only thing that's important here, there's 2 lines at the bottom that are lower than the line at the top, which was us. So very suddenly, we found ourselves in a competitive situation where the press was writing, Firefox is so slow on this new benchmark. Look how fast Chrome is, and look how Safari is not much slower either. So what we had to do is we scrambled. We put a crack team of like 10 best compiler builders we could find in the world, put them on this problem. OK, make our JavaScript engine faster to be as fast as the competition. This was not even necessarily driven by actual observation in the field as fast as JavaScript would help users. This was really mostly driven by the fact that the press was writing we are slow. And you have to respond to that. So if you look at the time scale here, August 3 is where we found ourselves in a situation that we were slower. And like by end of August, we have caught up by half. And then another 2 months later, essentially we had equalized the performance advantage of Chrome and Safari. So if you have ever done software, you can imagine what kind of like things we set in motion here to catch up this quickly. And this actually shows very impressively the power of open standards. Because what happened here is we were not competing over some strange feature that only we invented and only works in Firefox. Instead, what we were really competing over is that there's common standard, JavaScript. And we all implement that common standard, and that's what creates interoperability. And what we are left to compete over is how well we do that. So what we competed over here is how fast can we run JavaScript. And this is really the main reason that if you look at web technology and look at, for example, communication standards, this is why web technology moves so quickly, because there's this tremendous amount of competition between these different parties, and we have to compete for the user. If the press is writing that Firefox is slow, the user has a choice to use Safari or IE instead. So the user's going to go and use a different browser. So we have to compete for users every single day. We have to be the best on all the different implementations of these same standards. And that's what makes the things really cool, because it means automatically that it moves the performance needle and the implementation quality of the needle of the web very, very quickly. That's of course good for everyone, because it's good for the user. Browsers are getting faster. If you look at JavaScript and programming execution in the browser alone, the kind of performance improvements JavaScript has made every year over the last 5 years are mind-boggling. There's basically no other programming language ever that has had that kind of acceleration. Around 5 years ago, JavaScript was gaining probably in a ballpark of like 20x speed up per year. The year after, this slowed down a little bit to like 10x. And after a year after that, probably like 5x. Today, as part of this talk, I will show you JavaScript running certain demos where we are pretty close to the performance of optimized C++. We are within 2x or less of C++ code. If you compare that to other dynamically typed languages, you will see that there has been a tremendous amount of focus on the quality of JavaScript implementation because there's so much market pressure on us. So market pressure and interoperability are really the key factors that make the web unique as it advances and moves forward. Now, this has been a really great success story for Mozilla, because really the fact today that you have Chrome is one of our achievements, and we are very proud of that, because we have created a lot of standards, and we have created a competitive environment where all these different companies compete for you as a user to use their products. This is also what makes us a little bit different from other organizations, is that we have a mission. The Mozilla Foundation's mission is to create a competitive environment for the web and make sure that you, the user, you have choice. So the fact that today is competition, and it's very harsh competition, which is great other competitors, is really very much a winning condition for us. And it's something that we were striving to do, and we are very glad that we achieved today. Now, one problem that we have run into over the last couple of years is that while this worked really great over the last 15 years for the desktop, if you look at computing today, really, not many of you have brought one of these desktops to this room today. But I would bet that pretty much all of you have their cell phone with them. So technology is really moving to mobile. Everyone has a smartphone and a tablet and whatnot in their pocket. And if you look at the tablet and mobile landscape in general, that landscape is actually very, very different from the desktop landscape. So I explained to you a little bit about the importance of browsers today and how they compete with each other. The competition on these mobile ecosystems is very, very different. It doesn't really matter which system you want to pick. iOS was the first one that really made this kind of really comprehensive and interesting smartphone system a little bit over 5 years ago. And it has developed into a very different direction on a desktop. On a desktop today, really the operating system, like Windows, for example, really the only purpose it has, it's a bootloader. It starts your computer, it deals with devices, it helps you open your browser. And the rest of your digital life, more or less, you're living in a browser most of the time. At least I do, and I think many people do. If you look at the mobile environment, it's very, very different. So if you pick iOS, for example, the whole thing is a complete technology silo. It's completely controlled by a single vendor. So you have, of course, the Apple platform. Apple defined the platform, the APIs, even the language. Objective-C is it's kind of like an Apple-preferred or push technology. And it goes even further than that. If you would like to make an application for that, you have to stick it into an Apple store and pay Apple a certain amount of overhead from the sales price of that app. If you want to use ads, you have to use Apple Ads. If you want to use services, most of those are provided to you by Apple. So this is dramatically different from the web, where it's an open system, you have a browser, and people can just bring their services and plug it into those services. It's a silo. You're locked in. And that's actually really bad for the user, because the moment you buy one of these devices and you start buying some content, then it's based on Apple platform technology bought through the Apple store. And as a user, you can never take that anywhere with you. You can't just go to Android. If you have an iPhone and you buy an Android phone, all the movies that you bought, all the apps that you bought, you cannot take them with you, because they were sold to you by Apple, not by whatever the manufacturer of the other devices or Google. And they're built on Apple technology. They're built with like Cocoa and Objective-C. So they will not run on Android with Java and some other pieces of Google technology. So of course, Google's Android is not any different. And the technologies have different names. So the technologies are called Java and Dalvik and whatnot on the Android side. But in the end, it's the same story, that you have Google services, everything's kind of locked down and controlled by Google through a Google store and Google Ads. And it causes this division of these systems. So you have these different jails. They're all shiny and nice, but as a user, you have to kind of pick in which jail you want to sit in. And once you've picked one, you're stuck with it. It's very, very hard to change. It's also very bad, actually, for developers, because they face the same dilemma. If you decide to develop for iOS, you have to basically start from scratch. For Android, And of course, Microsoft's offering in this area is exactly the same. You just kind of use Microsoft technologies in XNA and C# and whatnot. So this very highly clustered, segregated landscape of systems that's very, very different from the desktop. And here, the native OS actually has a very important role. On the desktop, I don't really spend any time really interacting with the OS. Mostly my time is spent in the browser, like reading mail and reading content. On these systems, actually, people don't use the browser much at all because you use the native apps that these platforms bring. So to look at how we're going to change this going forward, really, all we have to do is kind of look at the past. What did we do in the past? Well, I led with this slide that shows that choice and innovation, we believe, are very important to having brought the desktop where it is today. And those are pretty much the pieces that are missing today in the mobile ecosystems, is that you don't have choice, as I just explained, because you are stuck in a system once you have bought it. And there's not a lot of innovation either, because as I showed you on a slide with this graph, innovation happens when there is competition and when the platform owner is terrified that the user is going to walk away. Every single day we get out of bed at Mozilla and we worry about how to make our product better, because you can switch any single day to a different browser. Once Apple has sold you an iPhone, they know that you are locked in. They own you. So it really dramatically slows down the speed of innovation and removes choice. And to restore the same kind of competitiveness on mobile, we have to do essentially the same things. We have to go and see what's missing in the technology side in mobile that the web cannot do and kind of fill in those gaps. And that's pretty much also what we did back in the desktop. I told you about ActiveX, this piece of Microsoft technology that nobody could duplicate. The reason that ActiveX took off was that, of course, it actually was filling a genuine need. It was adding things the web couldn't do back then. So what Mozilla did for many years is create all these new standards and work with others to create new standards to fill the technology gap. So really the existence of HTML5 and HTML5 having much, much more capabilities than the previous version of HTML, those were the ones that eliminated the need to have ActiveX around in the desktop stack and in the desktop web. The same is really true for mobile. If you look at a mobile device, 2 years ago, almost nothing is interesting about the device, none of the device capabilities. You could reach to the web. So that's why people are using and writing native apps, is because in the past, it was simply not possible to write as powerful HTML5 apps as you're writing mobile apps. So a lot of the work we have been doing the last couple of years is filling this gap. As some of you might know, we are, at this point, providing our own smartphone operating system, Firefox OS, targeting emerging markets. And a lot of the work around that was really kind of filling this gap and providing all the APIs that were missing in the past in HTML. And today, all these APIs exist, so today you can write as powerful HTML5 apps as you can write native apps. The big missing piece here, of course, is telephony. We have kind of filled in the gap with all the existing APIs, so you can write the same kind of apps you have on a phone, but really communication and real-time communication has traditionally been something that has been sorely lacking in the web. And that's, of course, where WebRTC comes in. And usually at this point, like, you've seen these presentations, like all these demos of like video conferencing and audio conferencing, and all that stuff is very important and very, very cool. But actually, personally, I believe that really the most compelling part of WebRTC is a little bit different. If you think about your smartphone today, like how many of you are still like making a lot of phone calls with that? I'm one of those people who like on the phone all the time, but not really pushing that button. I'm pushing all the other buttons. So communication and video and all these things are very, very important, but WebRTC brings some very, very unique and compelling things to the web stack that didn't exist before, amongst others, the capability to communicate directly with other instances of HTML5 runtimes that I think are really compelling and make WebRTC a particularly important missing piece in the HTML5 stack. A second piece of that is not just this ability to exchange data in addition to voice and exchange real-time data. It's also the fact that we can, for the first time, really bridge all these different devices together. And this is also, I think, where we can heal some of the rift that today exists with these ecosystems. So it is true that iOS is this complete jail that's locked down, and Android is the same. And even though we are developing now and providing now an HTML5 replacement for these closed systems, there's still a lot of users captured in iOS and captured in Android. And this is a second very unique part, I think, of WebRTC, that it suddenly creates the way for all these segregated worlds of the past. Like we have the desktop, and then we have these different mobile ecosystems, but also the traditional communication systems. All of these can be connected to one standard that spans not just the use of on the web of communication, but also back to the traditional telephony systems. All right, I promised you demos and not just slides, so let's look at some of those here. The first is going to show you some other form of communication that I think is really important and and WebRTC is adding to the web stack the necessary capabilities to show you that. So what you should see here in a moment is a web browser loading up some game content. There we go. This demo is called Banana Bread. This is an open source game that we have ported, and we actually have used here a tool that ports C++ to JavaScript and runs that. And this is the tool I was mentioning. So this really runs C++ code with about just as fast as optimized C++ code. So you can see it's like a first-person shooter. Two of my engineers here are running around and are about to shoot each other very severely. And in addition, they're doing some communication down there. You can see this kind of chat communication. So what happens in the background here is, of course, this runs in your browser, and it renders your screen content. And in WebRTC, data channels are used to exchange not just the chat information, but also the actual movement of these characters back and forth is exchanged directly peer-to-peer between the two browsers that are involved here. So both of these engineers are running currently a browser open with this game. And this is very unique because in the past, the web was really a much more like server-centric model. What WebRTC is adding now, motivated through communication for video and audio, is the ability to exchange data directly between these two peers. And that's very interesting because you just kind of imagine all the things that this opens up for us. On the one hand, of course, it allows us suddenly to do much better and more efficient communication for this. But also remember the things I said about portability and going across these different devices. So for the first time, you have the ability now to build much more comprehensive game systems that can span all these different devices because now the same communication channels are available. All right, the next video here shows you a little bit the potential of the technology I just showed you. The demo you saw previously, this was some open source game. We used that because we could very easily modify it and build into the WebRTC capabilities. But I want to show you that this is not necessarily just limited to kind of like toy quality gaming content. What you see here is a collaboration between Mozilla and a game company called Epic. They have an engine called Unreal. It's a commercial gaming engine. It's very popular. So a lot of the first-person shooters that you see out there are using their game engine technology. And this is like console quality 3D gaming. It's like high-resolution HD content and very intensive 3D use. And none of this uses plugins these days. So this is all pure HTML5 and JavaScript. It uses WebGL, which is a standard in the HTML5 family, to render 3D content. And the rest of the code runs in JavaScript. And as I said, this is roughly within like 2x or probably faster than optimized C++ execution. And the fact that we can do something like this today really all tracks back to the things I said about the competitive pressure of innovation and having these standards we all compete over. So what's driving us to make JavaScript this fast is the fact that the Chrome guys are just across the street and they are trying to make their JavaScript really fast as well. All right, last but not least, I have one more demo for you to see here. This came to me yesterday, actually. This is our Taipei-based Mozilla team. And what they're showing off here is, the phone here is a Firefox OS phone. And it's running a WebRTC demo. What's unique about this is this actually using H.264 for the video communication. And you're probably aware that there has been some intensive press around the collaboration between Cisco and Mozilla to add H.264 support to WebRTC on the web. That has been hampered mostly by the fact that H.264 is a patent-encumbered video standard. So it's been a very intense discussion over the last years. And of course, Mozilla would much prefer an open standard like VP8, which is not encumbered by patents the same way as H.264. Unfortunately, the situation we found us is that for the kind of devices like here, VP8 has traditionally had really bad support on hardware acceleration. So the quality of the video you are seeing here on this class of device, you would not be able to do this kind of like real-time, high-quality, high-resolution communication with VP8 because these devices, these mobile devices, are simply underpowered. They cannot do in a CPU the same kind of encoding, fast video encoding that they can do in H.264, where they have hardware encoding support. So this was the main reason that we felt that this collaboration with Cisco would make sense to add H.264 support to the stack so we can take advantage of hardware acceleration that exists in many, many devices today, and it does not exist for VP8. So we believe that this is actually really going to accelerate the spread of WebRTC because now we have removed the biggest obstacle that was holding back WebRTC in mobile. In the past, if you were trying to do this kind of communication, especially on low-end smartphones, you would get like basically a stamp-size image that you have to scale up because that's roughly the limit what a CPU could encode and decode in real time. This is the H.264 integration now, and this uses the hardware decoders of the system. We can actually now really do this kind of high-quality video conferencing on these devices that you use from iPhone, for example, where they're also using H.264 hardware encoding and decode. So the biggest contribution of Cisco in this was that Cisco actually volunteered to bring this also to the web, on the desktop web. On these mobile devices, it's actually less a problem because almost every mobile device today has already a licensed H.264 encoder-decoder pair, and many of them in hardware, as I said. It's a bigger problem on desktop, where there's a lot of desktop systems out there that don't have H.264 encoding. And what Cisco did is essentially Cisco promised to provide a plugin for every relevant desktop system for free that would provide H.264 encoding and decoding, and that plugin can be used by browsers such as Firefox. So we can simply download a plugin, and anyone who does not have on the desktop an H.264 encoder and decoder can use that plugin and can automatically, through that plugin, also communicate with these systems. So we will see how the standard side of this is going to shake out. Of course, as open source and open technology people, we are still rooting for VP8. But through the addition of H.264, we can also now cover this hardware encoding case, which is very important for the mobile use case. All right. Thank you very much. This is so much for my talk, and I'm happy to take any questions. I think I have 4 minutes left from this slot here. Thank you very much.